Now I want to show how to solve this triangle. In this case, we know two of the sides of the triangle, the hypotenuse and one of the legs, and we know that it's right angle triangle, but we don't know the other two angles. So let me write over here what we're going to find. We're going to find x, and we're going to find the angle alpha and the angle beta. We're going to begin by finding x. In this case, as we mentioned before, we won't only use the information we have. So we know it's a right angle triangle. We know two of the sides, one leg and the hypotenuse. We are trying to find the third one. So we're going to use Pythagoras. So we know that x squared plus 12.3 squared has to be the same as 13.1 squared. Pay attention here that the hypotenuse is the side that stays alone and is square on the right side here. When doing this or something similar in the assignment, some of you found what is the value of 12.3. In this case, you will find that is approximately 151. And what is the value of 13.1 square? Which is 172 approximately. These are approximations to three significant figures. And if you use these approximations, you will get that x is the square root of the difference between 172 and 151, which is 121. So that will give us a value of x of 4.58. Unfortunately, this is not correct because there is an approximation involved over here and there is another approximation involved over here. And our result here is affected by those approximations, so it's not precise at all. So I don't recommend doing the problem this way. You may be lucky and get the correct result to three significant figures or not, as we will see in this case when we try to solve it more precisely. And we say then that x squared has to be, I'm going to subtract 12.3 squared on both sides to say 13.1 squared minus 12.3 squared. That's the value for x squared, but actually I want to find x, so I need to find the square root of this. So 13.1 squared minus 12.3 squared. So let's use the calculator to find what is the value of x. I need a square root over here. 13.1 square minus 12.3 square. That gives me I'll write it over here. That gives me 4.507 and continues, but we just want to see whether the 7 is going to change the 0 or not. And yes, it does. So to three significant figures, this is 4.51 meters. So if you compare the two results we got over here, we got 4.58, and here we get 4.51. So we're actually off by quite a bit, 0.7. And the second one is a good result because we didn't use an intermediate approximation to find it. So this is the second method is what you should be doing, and it's not a good idea to use intermediate approximations because that's going to affect your final result. Well, not necessarily always, but on many cases. So you should avoid doing that. So this was just for finding the side we were missing. We are done with that. And now we want to find the angles. And now I realize that I call both of them alpha, so that's not correct. The second one is beta. Let's say we are trying to find alpha. To find alpha, we are going to use only the information that was given to us, so the information in blue. Over here we have this leg is the opposite to alpha, and this is the hypotenuse. So we need a trigonometric ratio that relates an angle, the side opposite to it, and the hypotenuse, and that's a sine. So sine of alpha is going to be the same as 12.3, the side opposite to it, divided by 13.1, the hypotenuse. So we are going to ask the calculator, what is the angle such that when we apply the sine function, we get a result of 12.3 divided 13.1. So we need to use the inverse of the sine for that. And if you do that with the calculator, you will get that is 69.87, and it continues. So approximated to three significant figures, this is 69.9 degrees, because the 7 does change the 8 that comes before it. We now wish to find beta. So to find beta, we are going to use the side that is next to beta and the hypotenuse. So we are going to be using the cosine ratio. So cosine of, that's not correct. Cosine of beta is adjacent to beta, we have 12.3 divided by the hypotenuse 13.1. So we need to use our calculator to know the angle that gives us that result. So we need to do the cosine inverse of 12.3 divided 13.1. You may stop the video and find this in your calculator quickly. And you will get that the result is 20.12, and it continues. So approximately to three significant figures, this is 20.1 degrees, because the 2 does not change the one that comes before. If we wish to check that our results are correct, well, first of all, on an intuitive level, we can see that alpha is the larger angle, 69.9, and is in front of 12.3, which is the larger side. And beta, which is 20.1, is in front of a side that is only 4.51. So that makes sense. But if we want to check, we can check that 69.9 degrees plus 20.1 degrees is actually 90.0 degrees, as we wish, since the triangle is right angle.